All right, so one problem with talking about things in terms of moles is that we don't, can't count out moles by actual counting. The way that we count moles is we count by weighing. And so our inputs and our outputs have to be masses. So for example, let's say we start off at compound A, and then we want to find out how much of compound B we're going to have. So we're going to start off with some mass of A, and then we want to end up with some kind of mass of B, usually in grams. So the way that we have to go from this is you can't go straight from mass to mass. You have to use some kind of conversion in between, and that's converting things to moles. So for example, we would go from mass A to the moles of A, and to do that, we would use the molar mass of A. After we're at moles of A, then we can use our stoichiometric coefficients to go to moles of B. And then finally, when we're at moles of B, we can go to mass of B using the molar mass of B. So you see, we have to do multiple conversions, but again, it's just conversion factors. Let's take a look at an example. So here we're going to have 2C8H18, which is known as octane, plus 25O2 to form 16 CO2 plus 18 H2O, right? So we're combusting octane. This is kind of what happens in your car. You take some hydrocarbons, you combine them with oxygen, you form carbon dioxide, water, and some energy that then powers your cars. Let's take a look at our question. Question is going to be, how many grams of carbon dioxide are produced when 2,700 grams of octane are burned, right? So we can see that we start off with mass, and then what we want at the end is mass, right? If we think about what we want the grams of carbon dioxide. If we think about what inputs we have this 27,000 grams of octane, or 2,700. So we're going to start off with that, 2,700 grams of octane. Note that I'm writing out the number, the unit, and the subject. That's going to help you a lot when you're doing your unit conversions. So we can see our first step is to go from the mass of A to the moles of A using the molar mass. So here we're not given the molar mass, so we have to calculate the molar mass of our octane. So our molar mass of our octane is going to be equal to the mass of 8 carbons and 18 hydrogens. So we have to use our periodic table. We see that each carbon weighs 12.011 grams per mole. So we're going to do 8 times 12.011 plus then an 18 times 1.008 for hydrogen. Do all the math there, you end up with 114.232 grams per mole, right? And so we're going to use that value there to convert our grams of octane to moles of octane. Note that the grams is up top here, so grams has to go down here in order to cancel out. The number follows that unit, so 114.232 grams to 1 mole. Now, if we think about what units we're at moles of octane. That's still not grams of carbon dioxide, so we have to think about what we do next. The next step is to use our stoichiometric coefficients to go from moles of one thing to moles of another thing. So in this example, we need 2 octanes to burn, and out of that, we get 16 carbon dioxides. So we're just going to write it like that. Note that octane is on the top here, so it has to go down on the bottom, with the 2 being the coefficient there. And then up top, 16 CO2. And now our octanes are going to cancel out. You see, that's the importance of including the subject. So that way you know where you're at. So now we're at moles of CO2. If you think about where we're at, right? Moles and carbon dioxide. Those are the units that are left. So that's where we're at. But that's not quite where we want to be. We want to be at grams of carbon dioxide. And if we think about how we go from moles to grams or vice versa, we use the molar mass. So again, now we have to calculate the molar mass of carbon dioxide, and it's going to be the mass of 1 carbon and 2 oxygens. So carbon is 12.011 gram per mole. And then we have 2 oxygens, each weighing in at 15.999 grams per mole. Do the math there, and you get 44.009 grams per mole. Now we can go ahead and plug that in here. Now you have to be careful, right? Moles is up on top, which means moles needs to go down on the bottom, and then grams goes up on the top here. So now it's 44.009 grams. And then the moles and the moles cancel out. You see how when you use this method, everything is nice and organized for you. You don't have to do as much thinking, and it leaves a lot less room for error to occur. Then you go ahead, plug that in your calculator, you get 8,321 grams of carbon dioxide. And then we have to think about sig figs. This here has 2 sig figs. So your answer can only have 2 sig figs, the 8 and the 3. After that is a 2, so that rounds down. So it's 8,300 grams of carbon dioxide as our final answer. So as long as you use the method, these problems shouldn't be too bad. Of course, watching someone do it is not really going to help you too much. You need to practice. So take a look at the work along. And if that's not enough practice problems for you, check out the extra resources. And if you'd like more, stop by office hours or a tutor.